I would like to introduce Mal. Mal will be presenting Kubernetes 101 for network professionals. Mal is a principal consulting engineer for network automation at Nokia and is coming to us today from Texas. This is Mal's second time presenting at NANOG 87 and third time on the NANOG stage. Mal's first talk at NANOG was called The Power of Kubernetes CRDs to Automate the Edge Network, and that was hosted at NANOG 85 in Montreal in 2022, pardon me. Welcome back, Mal, and it is a pleasure to have you back on the stage here at NANOG.
Hi, welcome everyone. Well, hopefully you're gonna like this content. I'm gonna start from the most basic stuff, containers, why the pods, and then I go and I'm gonna make it harder and harder until it's gonna get very complicated, okay? Bear with me. Well, let's start talking about first on namespaces. Well, for who doesn't know a namespace, and we're gonna talk about use cases and why we use it here. A namespace is a partition of the kernel in Linux. Probably you know that from Docker because you're partitioning processes, and you have a process that actually is isolated from the others in the host, and you're partitioning kernel resources for that. But also there is a partition for the network. Then you can isolate a piece of the IP stack on the Linux in the kernel from what you have in the host. And then you can have in this partition your own routing table, your own ARP table. Well, I put there, it's like a VRF, but actually there are many missing features of that. If you want BGP, you need to install another application to make it work. But more or less, it's isolated IP stack on the Linux. And you see the commands over there. It's pretty simple to just create one. You just go to Linux, and if you have the IP application running, but most of the Linux have it, you just need to go and create your own network namespace, and you can check, or you can start setting up all the IP settings directly through that command, okay? Do not confuse network namespace with Kubernetes namespace, okay? I got that question many times. Is Linux namespace, again, is a partition of the Linux kernel. Kubernetes namespace is just a pointer on the etcd value store telling, trying to split the Kubernetes in different teams. And then you create namespaces for different teams to work with their own applications. Then it's just a pointer. Then now we're going to talk about pod. Why is important to have a pod? What is the abstraction that we are getting from the pod? Why it's so useful? How we communicate or connect pods in between each other. Then let's start talking first about containers. Well, for anyone that is actually familiar with Docker, when you create an application, let's say here is a PostgreSQL, you need to start mapping a port from the application to the host, to the physical interface, or the virtual interface you're using a virtual server. Then if you have one application, it's not going to be a big deal. But if you have this more than the same application, more than one instance in the same host, you cannot reuse the same port number. Then you need to figure out maybe to use another port number in the same host. And if you have many replicas, maybe it's going to be some sort of a trouble. Then how we can solve that? And then is a pod is coming. The pod in the concept of Kubernetes is actually what you're doing is assigning a network namespace to a Docker, to a container. Then the network namespace is going to have interfaces, like you can create a interface in every pod as a virtual wire. And And you need to treat the pod like or the namespace like another host inside the Linux server. That is helping me to wrap this process, this container in a network namespace, and now I can use the same port number in every pod without any conflicting problem, like in the case of the host or the physical interface of the host. Here you see a YAML file, like an example. If you want to go to Kubernetes and just define a pod, a normal pod, those are all the instructions that you're going to need, and sometimes you need to put additional information like the password of the administrator. But you can say, okay, this is going to be the image that I'm going to use from the container, and this is going to be the port I'm going to map from the container on the pod. Okay, very simple. Those are a set of commands. Just want to show you that you don't need Kubernetes in order to create a pod. Even if you have the pod is a fundamental concept that we have in Kubernetes, you can create your own pod without installing Kubernetes using a normal Linux, using normal commands. You just need to create the container with no network, and then you can allocate the network namespace using the IP command, and then you can just go and create all the IP settings for every pod. You need to create first the virtual wire to interconnect those network namespaces, and then you're going to have communication between the both containers, both network namespaces or pods, like I'm showing here. I don't know if you've been also working with Kubernetes before, but when you go to the container runtime, like for example Docker or Containerd, you start watching what are all the containers that I have on my system. You're gonna see many containers called pods, many of those. Well, basically Kubernetes is putting a pods container inside every pod, because in case the application inside the pod is crashing, you want to keep that network namespace. And that is why you have another container in the same pod called pods, to keep that reserved. However, most of the time the pod also is crashing, then it could be a little useless. And all the IP settings are changing anyway, because every time that you create a new namespace, a new pod in Kubernetes is going to change IP addresses and all the settings. Now we're going to talk about the Kubernetes cluster fundamentals. Let's start talking about what are the components of a Kubernetes cluster. Well, in every Kubernetes, you're going to have a controller and the workers. If you are doing some sort of testing, also you can have the controller and the worker in the same node. You don't need to have split those in different nodes if you are just developing something or testing something. But if you are working on production, normally you have three nodes that are the controllers, and the workers are actually also independent from the controller, and you can have many of those. That could be very, very big. Everything depends on what are all the applications that you're going to run on top of that. And the components that you have in the controller, they're also pods. Okay? And then if you list all the pods in the controller, you're going to see there is a pod called Cube API Server. That pod have the APIs for Kubernetes. It's exposing the APIs, and it's dealing with the communication from outside to the cluster. etcd is like sort of database, or we call it also the key value store, where you have all the information for the cluster. You can have the all tokens and accounts, service accounts, and all the information that you're going to need. And it's always is using replicas. If you have 3 controllers, you're going to have 1 replica in every controller. It's very resilient. You have also the kube scheduler. That is, kube scheduler is watching how the compute of the workers, how much capacity you are having, and depending on that, it's going to start provisioning the pods of the application in some of the workers. You have the kube controller manager. That is the one that is managing all the things related to the service accounts, the namespaces, the tokens on the controller. The kubelets, you can have many different runtime container runtimes in the workers. You have Docker, that is one of the most popular, but you also have Containerd that is being started to be used a lot lately. Then kubelet is giving you is managing that part of the container runtime and keeping the pods running on every worker. And kubeproxy is the one that actually is managing all the network rules in all the nodes. Then every time that I'm setting a policy or security policy or creating a service, actually those are iptables rules that kubeproxy is taking care of create in every node. How the pods communicate inside a node is, well, the basic thing, and again, that can change because you can install different network plugins in CNI plugins in Kubernetes, and that can change the way that pods are actually, they're gonna start communicating between them. Here you have the bridge. This is the most basic way to communicate the pods. You have a bridge inside every node. You create a virtual wire between a pod that, remember, is a network namespace to the bridge. It's a Linux bridge, okay? And you are using a prefix that actually is the same subnet where everything is connecting, the pods all are connecting inside the same node. Now, how we can connect pods between different nodes, because you have cluster, you have 10 workers, you have pods that actually belongs to the same application or replicas, and they need to be connecting between them among different physical nodes or virtual servers. Then again, depends on the CNI plugin, but the most basic use case is you have a prefix as a route inside every host with the next hop going directly to the physical interface of the worker. Then every worker have their own prefix, and they use the routing information in every host to say, well, if you need to go to the pod that is in that host, this is the information, and this is the physical interface IP, the IP address of the physical interface that you need to connect in order to go to that prefix. Okay. Now I'm going to talk about the services. Well, it's nice to have all the pods and all the management, but I need to also start exposing those applications to the rest of the world, and I need the services for that. Then why am I going to need services? First, like I told you, it's very normal that a pod can crash or a Kubernetes node can crash. And then you're going to lose those replicas. And every time they are restarted, they change the IP settings. They change the IP address, okay, basically. And if you want to try to connect to those replicas, you need a stable IP address somewhere. Then services are helping you to define those IP addresses to make it easier for you to access those pods. They are balancing everything in the Kubernetes. Again, those are kubeproxy. Remember kubeproxy? Kubeproxy is creating all the rules to do that, okay, to expose those services through IP rules, at least for one of the services. And then you are load balancing all the replicas. Then let's say we have an Nginx service, and then I can put many replicas because I want to spread all the traffic through different nodes. Then I create a service with one specific IP, and Kubernetes is taking care of to balance that traffic among all the workers, all the nodes. And also, it's going to help me to expose the service inside the cluster, because sometimes I can have a database inside the Kubernetes cluster, and I don't need to expose that IP to the rest of the world. I just need the IP for the applications that are using that database inside the same cluster. But if I had a front end, I need to expose that service, and then I need something to do it. Then the most common service, or the file type service, is cluster IP. Basically, what I'm doing is assigning an internal IP that is an internal prefix. When you install the Kubernetes cluster, you can define all those prefixes. And that IP address is going to be only is going to exit only internal. Again, everything is managed through iptables using kubeproxy. And I'm going to define that cluster IP service, and I can provide that fixed IP or a specific IP address for any internal service inside the cluster. Then if I had a database that I don't want this database to be exposed, I can use that service for that. Now I need to expose some applications. I have different layers of applications. I have database, I have my backend, I have my front end. Now I need to expose my front end in some way, okay? Like an Nginx controller, for example. Then I can use the NodePort. And then those YAML file, that syntax is actually real. It's very simple. You just need to go and put I need a NodePort service, define a selector. Every time you create a pod, you can define a label. Okay? And that label can call it application, for example. I'm going to create a label for that pod called app, and I'm going to call that Nginx. Okay? Then when you create the service, you just need to go and select Nginx after your criteria for the selection, like I'm doing over here. Then you don't need to point every IP address of the pod. You just need to go on the label. Then if the pod is changing or you're putting more replicas, you're always going to have this service pointing to the right replicas. Also, Kubernetes have an internal DNS. This is why also you're having all that information exposed to every pod. And you define, and you can define, if you don't define in the NodePort, you don't define the NodePort number, the system is going to give you one of the ones that are available at that moment. And what's happening is for the NodePort, you have a specific range for that. It's going to create a port for in every host, in every worker. You're going to have you're going to expose that application in the same port number in every worker of the cluster. Then if you have an external load balancer that need to balance that specific application from outside, just know that this is going to be the exact port I'm going to use in every server on the cluster. Okay? Easy peasy. Then, but if you also want to automate the load balancer inside the Kubernetes cluster, if you go up to a public cloud like Google, Amazon, any Kubernetes that you are actually using from that service, they have that in their portfolio, then you can just go and from the Kubernetes, using the load balancer that is at the edge of your virtual data center or VPC, you can go and from the Kubernetes, define the load balancer type of service, and the Kubernetes through APIs is going to go to that load balancer, and it's going to create everything: the cluster IP service, the NodePort service, and the load balancer rules. Everything directly from the same Kubernetes. Okay. Also, inside the load balancer, you can define some policies. Because if you use the cluster IP service, that is nice, but you're going to be circling packets unnecessarily. if, for example, if the traffic from the load balancer is coming from a node port to a specific node to reach some cluster IP service that is directly, that is the same IP in all the nodes, maybe because it's doing load balancing, it's gonna again do another load balancing, and maybe it's gonna try to go to another different server to a different pod because it's part of the replicas. Then you can say, well, I don't want all the traffic circling that way, and then I'm gonna create a local traffic policy that I want to keep everything in the same node. Then instead to go to another node, it's gonna always stay in the same server with all the traffic. Then you have pros and cons of that. If you're using the local and not trying to keep all the traffic in the same server, the problem is maybe you're going to have too many replicas in one server that you're not actually touching because of that, and maybe the traffic is not being balanced in the perfect way that you are expecting. But the pro is you're avoiding circling traffic, and you are also having direct access for the source IP if you need to do troubleshooting. If you use the cluster, it can be better for the use of the resources, but it can give you more latency from the source IP, and it's going to skew the client source IP. Then it's going to be a little hard later for the troubleshooting. Okay. The standard is use the cluster. Okay, but probably if you are a network guy, you're going to use the local. Okay. Then, like I told you, we have many services. Then the load balancer is actually, in order to be created, you need to go first create a cluster IP service. Then it's going to create the node port, and then it's going to define all the rules in your local load balancer in order to access that application through the node port that you just specify. And everything is going to be that simple, like just defining the type load balancer service. When you create the load balancer, there is a setup part on the Kubernetes that you define what is going to be the prefix that the load balancer is going to use. And every time that you're creating a load balancer service, it's going to take one IP from that prefix, and it's going to tell you directly on the Kubernetes what is the IP address that it's using. Okay. There is another application of interest that is called Ingress, or Ingress controller. That is not an actual Kubernetes service. Okay. It's an application that you can install in your cluster, but it's also giving you layer 7 routing capabilities and other stuff. Okay. Then why is so important? Because many developers think that using the Ingress, for example, you have a web server, you have only one domain, but you have inside that server, web server, you have many different applications. And you want to start routing those applications depending of the path or depending of the subdomain of that domain. And you can use Ingress for that. That's going to give you intelligence for that. Then in this example, in the left side, I'm defining two different services that can be managed by two different teams, two different applications. And I have in the right side how I'm creating the rules in the Ingress when I create the application, saying, okay, when I'm going to one path, I need that path to go to that service and that other path to go to that other service. Then that way you can have different developers or the development teams working in different applications for the same website or for the same site. Okay. And you can use the load balancer to go over that Ingress and balance the traffic directly on the Ingress, because probably you're going to need at least 3 replicas of the Ingress, okay, for resilient and for performance. Okay, now let's talk about the CNI plugins, starting first with the Container Network Interface standard. CNI was defined because most of the time you have, well, in some moment, now Kubernetes is the most popular container orchestration platform, but you have Docker, you have Mesos. Then in some moment, someone told, okay, let's create a standard to start using the network resources in every pod to make the things easier. And then, like I showed before, remember the bridge? When you create a connection between two pods in the same node, then you need to connect that a specific pod to a specific bridge inside the Linux. Then there are some steps that you need to do in order to make that work. Then first, you need to create a network namespace for that container, right? Then you need to create the virtual wire. Attach that virtual wire to the namespace and to the bridge. Assign the IP address to those elements, to the pod interface. Maybe bring that interface up, and if you need, enable that. Okay? And you have all those steps, and those steps are the same in any container orchestration platform. It's not changing at all. Then what we are doing with the CNI is defining a specific way to call every type of network device that I'm actually setting up in every cluster. Then if I have one that is the most common is the bridge, this is the way I'm going to call it. Then to call it, I say, okay, I need to add network to a pod that is identified with that ID, and I have the namespace that is identified with this other ID. Okay. Then doing that, if I want to start using any CNI plugin, you don't need to even see that when you're creating a pod. I'm just saying how it's working, behind. But when you're creating a pod, actually, what is happening is invoking that network plugin using add command. When you are deleting a pod, it's invoking, again, the same plugin with del, delete. Okay? And the other standard is all the definition of the CNI plugins are going to be using JSON with a specific format. Okay? Then thanks to that, you can create many other CNI plugins. Then when you have Calico, Cilium, all those guys, actually everybody's using the same standard in order to make it work with any of the container orchestration platforms. If you want, you can create your own plugin also. There is a blog post that is telling you how to do that. Then if you want to have your own plugin, you need to create those elements. You need to specify the network namespace, what is the container, and you need to put all the results of that operation in a specific format. Down there, you can see there are some of the most common plugins. You have, well, the bridge is the most common one. Yeah? It's just to have a Linux bridge and connect all the pods to the bridge. You have the MacVLAN. MacVLAN is MacVLAN, IPvLAN, and there is someone is missing is SRv6. Those are very common on the telco space. Okay, I'm going to talk a little more about those, but the idea is they are normally they are built in every Kubernetes cluster. You don't need to install anything specific. If you are going to use something like Calico or Cilium, then you need to install the CNI plugins and make it work. Okay, MacVLAN. I don't know if you had experience, but when you go to a Linux server, you can create like use any specific port, and you can just go and add a secondary address to that port. And you have the option, if you want, you can create even a new MAC address for that port. But basically, MacVLAN is doing that. Is you're using a specific address in your interface on the host, and you're adding an IP address and a new MAC address for that. Okay. A good thing of MacVLAN also is you can attach a specific VLAN ID on that interface to a specific MacVLAN interface. Then if you want your pod going directly to a PRF in your router and a specific VLAN, this is a way to do it, for example. And then you're going to be isolating all the traffic that is coming from the router to that pod through that way. Okay. You also have IPvLAN. If you don't care to create MAC addresses because you don't need them, you can just go and create secondary IP addresses only. And all the IPs are going to use the same MAC address, but again, you can also attach a specific VLAN ID to every IP VLAN and do the same thing. Okay. There are two different IP VLAN. The most common is the layer 2, that you're using only one prefix inside the host. And there also is the layer 3 that you are actually creating different prefixes in the same host. But in order to make that work, you need some routes from the outside router that is connecting to. Let's talk about Calico. Okay, Calico is not a built-in CNI plugin in Kubernetes. It's something that you need to install. Then you need to go download from GitHub the manifest and run the manifest through a kubectl command. Okay. Then as soon as it's installed, the way that Calico is working is a pure layer 3 solution because it's using /32 addresses directly on every node to direct to access every pod. Then it's using the IP stack inside the host, but it's also using another project called Bird that is a BGP solution for Linux to do peering everywhere for that IP stack. Then all the information through Bird is going to go, for example, you can do a BGP with the other host in the same cluster, and then all the prefixes that you have over there actually is going to come as a route directly here because of the BGP. And then everything is going to be contained in the IP stack. Okay. Then I'm going to start talking about problems of scalability with that. But let's start understanding first the Calico, how it's working. Then when you start Calico, you create a pod. It's going to create a virtual wire. And this virtual wire is going to go to another wire that is going directly to the host with that complex name, Calic something. And you're going to put the address, and then it's going to create a route to say, if you want to go to this pod, to this address, you need to go through that interface. Okay? And this is going to happen for every pod that you're going to create in that same server. Now, I need to connect that with other pods in other nodes. Then I have another project called Felix. And this is when the BGP Bird, the project is coming. Well, Bird is actually open source, by the way. And when what is happening here, because of the BGP, I have all the information of where is one node and the other. But I need to set something to start connecting the different elements. Then I have the option to use physical interfaces on every node, or I can create a tunnel. Then Calico also gives you the option to start using a tunnel, a VXLAN tunnel, because sometimes you are not connecting all the nodes in the same subnet. Sometimes they are in different locations, and you have a more complex layer 3 elements, and the fabric interconnecting those elements. Then probably in that case, you need a tunnel. And then if you are using Calico, the most common is you have a subnet, you connect all the nodes, and everything is going to be perfect. Or you can use a tunnel like VXLAN to interconnect the nodes if the subnet is not helping. Another way to escalate that solution is if you have too many nodes. Probably if you have 8 nodes, it's going to be fine to have just everything using the IP stack directly in every server. But if you have more than this, probably you need a route reflector in your fabric. Or you can be pairing directly with every leaf directly in the rack. And that way you're relying all the routes directly on the fabric and not putting that in the IP stack of the Linux server. That maybe is not the most efficient way. Okay. This is an example how Calico is defined. Again, CNI is defining a standard, a JSON standard to define every plugin in Kubernetes. And then this is the way the Calico is actually setting up every scene. And I should have, I don't know if you can read the blue part, but it's saying Calico and Calico IPAM. Calico also, part of the standard of the CNI, the plugin needs to also define the way that is going to assign the IP addresses, the IP settings. Then you need the IPAM as part of the configuration of the CNI plugin. Okay. And there are many plugins. Okay, I just got this online. Doesn't mean that I'm totally agree with this analysis of every CNI plugin, but it's just a good view to understand what are the CNI plugins that are around. Antrea is one, Calico, Canal, Cilium, Flannel. Flannel is very popular because it used to come always with every cluster, with every installation of the Kubernetes. I haven't seen this lately. And Calico is also is a solution that is used in telco cloud deployments for the management interfaces. It's very popular on that. I'm seeing also Cilium. Cilium is something that Google is pushing very hard with Anthos, their own distro of Kubernetes. And they are doing also important things with Cilium in order to improve the performance for the network operations. Now we're going to talk about Multus. This part is more related to telco because probably you're not going to see anything with Multus in any enterprise customer. Okay. Multus is coming up because when you are installing a cloud-native function on Kubernetes, let's say you have a router system, part of the packet core on 5G. And you need to connect that system to so many different destination endpoints that you need multiple interfaces in order to make it work. The problem is Kubernetes didn't think about that at the beginning. You only have one interface. Then Multus, the idea of Multus is create like some sort of meta plugin. Then Multus is like tricking Kubernetes saying, I'm your plugin, but behind Multus, actually, you are defining all the network attachments or all the additional CNI plugins that you need to create multiple interfaces for every pod. Okay? At least this is the way that I see it. And then when you need to connect, for example, let's say cloud-native function, and you need, let's say, 3 different interfaces, then you have the default interface that could be Calico, that is, like I told you, is very popular in the telco cloud deployments, because it's free. And I'm seeing some people using enterprise, but more in the enterprise business, not in the telco. And you need to add additional interfaces to go to some specific endpoints, maybe even define some VLAN, a specific VLAN for those elements to go to a specific routers or devices in the network infra. Then you can add as many plugins you want through Multus. And the good news is you don't need to add those on the setup. You can add those directly as another application using a YAML format. It's very easy. This is an example. And again, sorry for the blue box there. I thought it's going to look better. And this is an example. You have here the meta plugin using Multus. And inside that, using also JSON, you define the different plugins that are going to be components that you can call from every container. If I define the CNI plugin, doesn't mean that I need to use all the CNI plugins that are defined in Multus. I can just call it in the definition of every application. Okay. Then In this case, well, I put the white fonts there. I don't know why I did it here, no, in the previous one. You see here, I need to create a pod with a specific connection to one interface in my host, because maybe the host have also multiple interfaces. I have the 0, the 1, and now I need to connect one specific port of the pod through the interface 1, because this is the one that is going to a different backhaul, on the edge. Then I define the network attachment using the Multus format. And I say, OK, this is going to be the CNI version I'm going to use for that plugin. This is the type of plugin I'm going to use. This is going to be the master interface I'm going to use in every node on the cluster. If you have nodes that are actually named differently in the cluster, probably this is not going to work. Okay. I'm going to use the mode bridge for the connection. Means I'm going directly through that interface to anything that is connected to that interface. I'm not bothering to connect to anything else. And you can define the IPAN details of how do you want to make it work. You can even define some routing information if you need that to have it in the pod. And then when you create the pod or you create the service, I'm creating a pod over there. I just need to call it through annotations. Then I add a field when I create an application called annotations, and I just need to call it that way. Okay, and also can define the name of the interface of the interface of the CNF plugin. Everything depends on the requirements of the CNF application, of the instance that I'm trying to create here. And then when you inspect the pod, and I want to see what actually was created in that pod, you see, I have two interfaces now. One interface is the management interface that is part of the Kubernetes implementation. And I have a second interface now that is using that CNI plugin that is going through the interface 1 in that host. I told you it's going to be harder and harder. And well, another question is, do we have security policies also in Kubernetes? Yes, we have. If you don't use them, you can connect every pod with any other pod, even if they are in different namespaces. Okay. Then if you don't, probably you don't want to have that, then you need to start defining policies. And the policies also depends on the CNI plugin that actually you are using. Okay. Then you can define policies, and as soon as you isolate one pod, any communication from this pod to any other is going to be cut off immediately. Okay. Then you can start defining, use different rules, and those rules can be called using pods, using labels, or using namespaces, or going with the most normal thing that is using prefixes and port numbers. This is an example. You can just go using the same Kubernetes, create a network policy, define a pod selector. I want this application that have the label role DB, for example, and I can set up what are the prefixes that I need to block on that and the prefixes that I need for the egress of that traffic. Okay. Then, yes, we have security policies, network security policies. Then this is what I have for the 101. But now I'm going to talk about what is new in Kubernetes. Now you have the foundation, the fundamentals of Kubernetes, and you can understand all the features that you can get from Kubernetes and all the details. I'm going to start making the things even more complicated now. eBPF. This is new. I I think Cilium is the one that actually is pushing this pretty hard, is, okay, iptables is really nice. It's been there for a long time, but it's not too efficient when you need to grow this massively in many CNF applications, and you have to control and manage many flows. Then eBPF is something that was created. When you have any application in Linux, normally you install those applications in the user space, right? Any application is going to be working in user space. You're not going to touch the kernel. You don't want to touch the kernel. Okay. Now eBPF gives you the option to create small programs in the kernel. And the most important use case right now on this scenario is, how can I start modifying flows on the traffic using eBPF? There are many restrictions. You don't even, probably you're not going to touch any code related to eBPF, never, because everything is being abstracted through CNI plugins. Okay, but as I think it's good to know, those eBPF are running like small programs inside the kernel using the kernel resources. Okay, it's very restricted. You don't have, for example, loops. You can create loops on that program, things like that. And you can map those to the specific events on your user space. Okay. Then using that, Cilium is replacing kubeproxy. Then it's making things, like I told you, more complicated, because now Cilium installed an agent that is going to do everything regarding rules, modifying flows at the servers at kernel level. Okay. And why is doing that? For performance. Then what they claim is actually they can give way more performance using eBPF. Okay. Instead to use iptables, I use BP filters that actually are based in eBPF, and I can have almost 6 times more performance in my server. Okay. This is something new. Other new thing in Kubernetes are the CRDs, custom resource definitions. Why I need a CRD? When you normally install an application in Kubernetes, those applications, they have their own API interface. Let's say we install a database, and I have the access to the database directly through a NodePort, right? Using the services. Perfect. But sometimes the APIs are too proprietary, and it's hard to find another applications to work with those APIs. Then Kubernetes said, well, a good idea is why to not extend the APIs in Kubernetes, adding more resources, more elements. And then they created the CRDs. Then now if I need to change, or I need to modify, or I need to say anything to any of the applications inside the Kubernetes, I can use the same Kubernetes APIs. That's pretty smart, because if you put it, for example, in our case, how Kubernetes is starting to see automation in the network space. They say, let's create CRDs of the different network devices in the infra. Let's say, for example, I can import the full YAML model of a router as a CRDs inside the Kubernetes. And now I can do whatever I want on the CRDs through the Kubernetes APIs. I can use GitHub to put all my single source of truth and use all the elements that I have in the CI/CD concept on Kubernetes, that any change is going to be propagated immediately to my Kubernetes. I only need a controller that takes that information and reconcile that to my network devices. But we have elements like GNMIC, an open source project. There is, and this afternoon we had a tutorial, by the way, of GNMIC, that it can run directly in Kubernetes. You can take the data from the CRD and through GNMI do any change to any device in the network. Then I can define my state, my desired state of the network directly in Kubernetes APIs or intents, helm, kubectl, or manifest. And the good thing is going to be also machine capable to be read. I can have, for example, Argo CD to work and manage that information directly. Like I told you, there is a rich ecosystem around that kind of things. Then I can have machine-to-machine actually controlling my network, thanks to that. And I can use GNMIC to start doing all the changes and reconciling that desired state of my CRDs to my network devices. And GNMI also have beautiful things like telemetry. I can get all the events directly from GNMIC and see if maybe my changes are not working, and I can just change that back, or I can adjust this depending on specific events on my network. Okay, then I can go and go. There are many things that I can do with something like that. Then an example of the CRDs is Daniel Bernier in Bell, Canada, and I'm saying his name because actually he had many videos online. You can tell that I'm actually providing confidential information. He has many videos talking about how I can use, for example, SRv6 from the Kubernetes. Then SRv6 have some benefits in segment routing, like I don't need to use MPLS labels on all the transport. I just need IPv6 addresses in order to make it work. Then what he's actually working with Cilium is they define using eBPF. Everything is being processed with eBPF, and using CRDs to start putting all the configurations that he's going to need in the ingress route for that SRv6. You can make the cluster or Kubernetes cluster to provide different ingress routes for the segment routing directly from the cluster. Okay, and everything through just defining the CNF application with using the Cilium agent from the annotations. It's very easy. But maybe the network operators doesn't want some part of the network information to be part of the Kubernetes. They would like to have everything in the network. I don't know. It's still pretty new, but I think it's a nice concept that you can show how you can rely on the programmability of segment routing and provide something directly from Kubernetes to go from one place to the other, and just let the transport to be just a dummy IPv6 router. Okay. Another approach is I can use the GNMIC to start doing changes directly on the router, and then I can use the Kubernetes APIs, use the CRDs, and I don't need to rely on Cilium, and I don't need to specify anything on the cluster, but I can use the Kubernetes APIs to set up all my egress routers for segment routing. That could be with segment routing MPLS or segment routing SRv6 directly on every location. That also can be a good option to do that. This is why the CRDs are so important. Okay, it's a very simple concept, but it can be very powerful from the point of view of how much power it's going to give you from the point of view of have all the applications around Kubernetes to be part of that automation process. Okay, and maybe that can make more sense for some of the network operation in the way that everything is going to stay in the network, and then I can keep using the same assurance systems, and I don't need to deal with that information inside the Kubernetes. And I troubleshooting, I don't want that. I don't know. Everything depends of the use case. If the network operations also is taking care of the Kubernetes, maybe it makes sense. There is another project that is using CRDs that's called Nephew. And what Nephio is doing is a project that started by Google. It's a Linux Foundation project, it's an open source. You have companies, many service providers and vendors, including Nokia. I see Nokia, I think we have Red Hat, we have also, we have, I think, Bell Canada, I think it's T-Mobile. There are many providers actually working on that project. And the idea is, how can I start providing 5G packet core and Cloud RAN in an easy way in many locations, but I automate that process through using the same Kubernetes that probably I'm using for those CNF applications, and have something at the top level that is going to be orchestrating all those clusters, the cluster of the clusters, like a meta controller at the top of that. Then this is a new project, but the idea is through the CRDs, I can define everything that I'm going to need from the cloud infra, everything that I'm going to need from the Kubernetes cluster, and everything that I'm going to need from the CNF application itself. There are many videos online if you want to see how right now, what is the status of the project. But it's a very interesting thing because maybe that can be also extended to many other use cases, not just 5G packet core and Cloud RAN. Thank you. That's it. Questions?
Yeah, any questions out there for Mao?
Hi, Tyler Bigler at Home Depot. I was just curious if there was any courses that you would recommend that maybe use on your team internally when you have new hires or new engineers come on board for learning Kubernetes, or are you mostly hiring people that are already kind of involved with it and stuff?
Well, YouTube is a really good resource for that. There are many one-on-one courses for Kubernetes. Maybe not all of those are actually intended for network professionals. Okay, there are many stuff around the applications, but they are. If you go and ask, for example, start looking for Multus specifically, or Calico, or CNI plugins, you're going to get a lot of information.
Thank you.
Excellent.
There's another one.
So you said originally that out of all the CNI plugins, that Flannel was actually widely used at the beginning. Is there a reason for...
Can you be a little closer?
A little closer. Can you hear me now? Perfect.
Oh, yes.
Okay. You said originally that Flannel, out of all the CNI plugins, was widely used at the very beginning. Is there a reason that it fell off in use?
I don't know. I haven't actually checked that. When I was installing everything the Qt add, that it was the basic Kubernetes that you install directly from any Linux. Flannel was always the thing that it was coming with it. But lately, I'm seeing that I'm using Kind. That is a much easier solution to start testing Kubernetes because everything is working in containers. I don't know what a specific plugin is using, but I realize that it actually is not Flannel.
I guess a follow-up question would be, if I'm very interested in large amounts of UDP traffic, what CNI would I be?
What kind of traffic?
UDP.
UDP, okay. Well, if you're using UDP traffic, maybe, well, you are familiar with the SRv6?
Not really, no.
Okay. Most of the CNF applications in telcos are using SRv6 because it's going directly to the network card for all the processing. And then you don't need to rely on the kernel or anything in the IP stack in order to make that work. IPvLAN, MacVLAN are relying on the kernel, but SRv6 is going directly to the network card. That could be something good, or there are others that are using DPDK, and also can be a good option for UDP.
Thank you.
Got one more over here.
Yes, I have one more question. Can you share with us your experiences with multicast traffic?
Ooh. No, I don't have any reference for multicast. It's a good question. Let me take it off, and I help you with that. But no, I don't have a specific reference for that.
If we can get another round of applause for Mao, that would be great.
Thank you.
Thank you, Mao.